Hello students, welcome back. Now that we know about finite state machine, we are going to talk about their representations for easy understanding. So in this video, we are going to talk about that how can we represent a finite state machine, and we will discuss two different methods. The first one is a graphical method and the second one is a tabular method. So let us get started. So first of all, we have to see that how can we represent a finite state machine. We saw a graph that was describing a finite state machine in our previous video. We were able to interpret some of the properties from that graph. We had shown that in that graph there are a certain number of fixed states. We had few arrows which were going out from few states and they were merging back at a different or the same state. Now, how do we interpret such diagrams, and is there any other way that we can describe a finite state machine? So, first of all, let us discuss about the graphical method to represent the state machine, and these graphs are also called state diagrams. In a state diagram, every state is represented with a circle. The name of the state will be written inside the circle. So if I have 5 states, I am going to have 5 circles, and inside every circle a unique name will be written. Every transition from any state to any state will be represented by an arrow. The direction is very important because it will tell us that we are going from which state to which state. On top of every arrow, there will be two numbers separated by slash. On the left side, we write input. On the right side, we write the output value. Output in some cases can also be written inside the state circle. That is done mainly in case of a Moore's machine because the output is not dependent on the input. So here we are going to construct a simple finite state machine using the state diagram. So whenever we are given this task, we have to first start with the initial state. Then we have to think that how many inputs are there. If I have n number of inputs, from every state n number of outgoing arrows should be there, and then we will decide that what is going to be my next state for every input. Then we will create some new states and we have to go to every possible state and again repeat the process. That means again consider n outgoing arrows and make the transitions. Every state will have same number of outgoing arrows because every state can be given the same number of inputs. Whereas the number of incoming arrows on a given state may not be same because more transitions can converge on a single state, so that can be different. Now we are going to construct one FSM which is having 3 states and 2 inputs. So first of all, I have my S initial and the name I have given is S0. This is my initial state. So here I have 2 inputs. The first input is 0 and for that input the output value is P and the next state value is S0. So that is why the arrow is coming back to S0. When the input is 1, the output is P and my next state is S1. So we are transitioning from S0 to S1. Now we will consider S1. If the input is 0, we are transitioning to S2 and the output is Q. And when the input is 1, we are transitioning to S0 with output value P. Now S0 and S1 they are completely covered. Let us come to S2. In S2, when the input is 0, output is Q and the next state is S2. And when the input is 1, the output is P and the next state is S0. So this is how we have defined all possible cases for all the states, and we can interpret this finite state machine using this simple state diagram. Now we have one more approach which is called state tables. This is a tabular method to describe the same finite state machine. We are going to represent inputs, states and outputs. We are going to mention present state as well as the next states. So here we can make different tables for calculation of next state and output, and sometime we can do it in a single table as well. So here we are going to make the state table for the same example for which we had made the state diagram. So here we have our table and let us understand it. So we have our present states, our inputs, and we are going to calculate the next state values and the output values. So you can see that I have three values for present state: S0, S1 and S2. If the input is 0, S0 is transitioning to S0, and if the input is 1, S0 is transitioning to S1. When our present state is S1 and input is 0, we are transitioning to S2, and for 1 we are transitioning to S0. When the present state is S2 and input is 0, we are remaining at S2, but for input 1 we are transitioning to S0. Similarly for the outputs as well. If the present state is S0 and input is 0, output is P. If input is 1, then also output is P. For S1, for 0 the output is Q, but for 1 the output is P. Similarly for S2, for 0 input the output is Q, and for 1 the output is P. We can see that this method is also describing the same state in a very different way, but a comprehensive way. State diagram as well as state table, both of them are very easy to understand. So students, now we know that how to represent a finite state machine. Let us implement one such machine in our next video. Keep learning. Thank you.